In Dirac theory, today we are going to discuss a very important problem, and this is regarding the negative energy states. You may also say that we are going to discuss the theory of positron or hole theory. Okay. So how this negative energy states or theory of positron or hole theory can be explained on the basis of Dirac theory, we will see. Actually, after the theory, after Dirac given his equation, in fact, after 2 years of the publication of his original theory, he gave or proposed the interpretation of hole theory or positron theory, or you can say the explanation of negative energy states. You know, when the Dirac particle is placed in an external electromagnetic field, then the form of Dirac equation you have studied earlier is in this form. This is E minus E phi minus alpha dot Cp minus Ea minus beta mc square psi equal to 0. This is Dirac equation in electromagnetic field, and you have studied this equation previously in my lectures. Okay. Now you know that the relativistic energy E is given like this. This is plus minus root over P square C square plus M square C4. Okay. This is C square. And so the energy may have both positive and negative values. Okay. In fact, our aim is to explain this negative energy states on the basis of Dirac theory in present lecture. As you know that this Dirac equation may be written as 4 equivalent equations, and you have already written those 4 equivalent equations in the previous lecture. Actually, among those 4 equivalent equations, 2 corresponds to the positive energy and the remaining 2 correspond to the negative energy states of the particle. Okay. Now, the negative energy state is classically excluded. It can be classically excluded on the physical grounds. But when you talk in terms of quantum mechanics, then you can't exclude this negative energy state or the negative value of the energy, because in quantum mechanics you know that energy changes take place discontinuously from one level to another, and the transition from the positive to negative energy states and vice versa, that is from negative to positive energy states, are allowed. So while talking about this problem on the basis of quantum mechanics, we can't neglect or we can't escape from the negative value of the energy. Okay. So this was a vital problem, that if Dirac equation is valid, it holds, then definitely it should explain the negative energy states too, apart from the positive energy states. In fact, till now you have studied the several successful explanation of different phenomena on the basis of Dirac theory, like we have studied the spin and magnetic moments of the electron, and Dirac theory successfully explains the spin and magnetic moments of the electron, or you can say Dirac particle. In fact, we will also see that the fine structure of hydrogen atom, a positive definite probability density, invariance under both proper and improper Lorentz transformation, these phenomena can be also explained successfully by Dirac theory. So there is only one aspect of the theory that depends our sense of triumph, the negative energy states. Okay. So far, we have avoided facing this problem previously, but clearly a solution to the problem of negative energy states has to be found if the Dirac theory is to survive, as I have told you. Okay. In fact, we have seen that the negative energy solution cannot be lightly brushed aside, since the positive energy solution alone do not form a closed Hilbert space. So if it is necessary in quantum mechanics that the solution must form a closed Hilbert space, then you have to also consider the negative energy states along with the positive energy states. Okay. So in fact, to deal with this problem, Dirac postulated that the interpretation of the negative energy states known as theory of positron or the whole theory, this was proposed by Dirac on the basis of two postulates. Okay. So I have mentioned it here that the objective was to explain the negative energy states of electrons are not observed, though they exist. Okay. Negative energy state of electron are not observed, but they exist. And so for this, Dirac relied on Pauli's exclusion principle, according to which, you know, Pauli's exclusion principle, that in any quantum state, only one spin half particle can be. Okay? It means corresponding to a particular quantum state, there will be only one Dirac particle, that is only one spin half particle. Okay? And on the basis of this Pauli's exclusion principle, Dirac proposed two hypotheses to form the whole theory. And what are those two postulates? You can see it here. The first postulate proposed by Dirac was in the normal state called the vacuum. Normal state, which is called vacuum, that is the negative energy state is called actually vacuum because it is not observed. So this negative energy state is also called vacuum. Okay. So don't think vacuum in a literal meaning. Here the term vacuum has been used for the negative energy states. Okay. And according to Dirac's first postulate, in the normal state called the vacuum, all the negative energy states are occupied while all the positive energy states are empty. Okay. You can see this diagram where I have shown that this is the negative energy state marked by the energy of electron equal to minus mc square. How you can say that this energy state will be minus mc square? Actually, as I have written earlier, that E is equal to plus minus root over P square C square plus M square C4. Now, if we consider that our electron is at rest, then this P will be equal to 0. And so, in that condition, the value of this energy E will be simply equal to plus minus mc square. So this plus mc square represents the lowest state of energy state of electron, that is lowest positive energy state of electron, and this minus mc square represents the highest negative energy state of the electron. So this line actually represents the state of electron having energy minus mc square, and this plus mc square actually represents the lowest energy of the positive energy state. Okay. So according to Dirac first postulate, this negative energy state is completely filled with electron. It is completely occupied by the electron. While in normal condition, this positive energy state is completely empty. This was actually the first postulate of Dirac. Okay. Now, the second postulate says that only deviations from the normal vacuum and not the vacuum itself can be observed. It means this negative energy state is not directly observed, but when there will be any type of change in this negative energy state, that change can be only observed. When there will be no change, you can't observe this negative energy state of the electron, but when there will be any type of change in the energy, this negative energy state, that change can be observed. Okay. So this is actually the second postulate of the Dirac. Okay. Now let us consider that we incident an electromagnetic radiation on the negative energy state of the electron. Okay. And so suppose we add a positive energy electron to the vacuum. Okay. And as all the negative energy states are occupied, so this electron cannot make a transition to the negative energy state. Okay. What does it mean? It means if you if you try to provide energy to the electrons in positive energy state, okay, and to get the transition from positive energy state to negative energy state, that will be not possible, because the negative energy state, you know, is completely filled. So according to Pauli's exclusion principle, no electron from any energy state can be transferred to this negative energy state. Okay. But when sorry, so I have mentioned it here. You can say that then suppose we add a positive energy electron to the vacuum, as all the negative energy states are occupied, so this electron cannot make a transition to the negative energy state. Okay. In fact, the stability of the positive energy state is thus ensured. Okay. Though the vacuum is unobservable, but remember that it is not inert. It can interact by virtue of its electric charge with an external electromagnetic field. Okay. And that's why if we imagine that a gamma ray of energy h nu greater or equal to 2 mc square. Why 2 mc square? Because you know the difference of the positive and the minimum energy separation or minimum energy difference between the positive energy state and the negative energy state is what? This is mc square minus mc square, that is 2 mc square. So if we consider that the energy of a gamma ray is greater than this 2 mc square, and that interacts with the vacuum. With the vacuum means that interacts actually with the negative energy state. Actually, in that condition, what will happen? In fact, one of the negative energy electron in the vacuum can absorb the gamma photon, and after absorbing the energy h nu, which is greater than 2 mc square, the electron in the negative energy state may jump to the positive energy state. So I have marked it here that one of the electron which absorbs the energy of gamma photon makes a transition. You can see this figure. This transition is from negative energy state to the positive energy state after absorbing the gamma photon. Okay. In fact, this transition of an electron from the negative energy state to the positive energy state leaves a vacancy, and that vacancy is called actually hole. So you can see this figure. I have marked this by this hollow sphere, a small hollow sphere. This is hole. Hole is nothing. This is just the deficiency of electron or vacancy created by the electron. So the electron in this negative energy state absorbs the gamma photon and makes a transition from this negative energy state to the positive energy state. Here I have shown this electron which has been transferred from negative energy state to the positive energy state by this small sphere. Okay. Now, how does the hole appear to an observer? This is just a problem. How this hole will appear to an observer. So to know that how this hole will appear to an observer, let us consider that the energy of, not energy, but let us consider the charge of the vacuum is Q naught and its mass is M naught. Q naught represents the total charge of the vacuum. Vacuum means which is completely filled with the electron in negative energy state. And M naught is the mass of the vacuum in unperturbed condition. It means these are charge and mass when no gamma photon has interacted to the negative energy state. In that condition, in that unperturbed or undisturbed condition, Q naught represents the total charge and M naught represents the total mass of the vacuum. Okay. But when the hole is created, that is after interaction with the gamma photon, when electron gets transferred from negative energy state to the positive energy state, then let us consider the charge and mass of the vacuum, that is the negative energy state, are changed, and let us consider that after creation of the hole, the charge of the negative energy state or vacuum, you can say, is Q and its mass is equal to M. So now what will be these Q and M, you can easily understand. As you know, the initial charge of the vacuum was Q naught, and now one of the electrons has been transferred from this negative energy state to positive energy state. So the total charge after creation of hole or after transfer of electron is Q, and that Q will be equal to Q naught minus E. But you know that this E is the electronic charge, and electronic charge is negative, that is less than 0. So actually when we will substitute the value of this E, we have to put here minus sign. So this will become plus. And so actually I have written here minus E, but as E is negative, so this will become plus. And if it is plus, then the value of this Q will be greater than Q naught. Are you getting the things or not? Since E is negative, so when you will put this Q equal to Q naught minus E, that will be equal to Q naught plus E. So this is greater than Q naught. Okay, this is greater than Q naught. Similarly, as you can see, the energy of electron in the negative energy state is minus mc square. So if energy is minus mc square, so you can guess that the mass of electron here is negative. You have to consider because energy is mc square, but here energy is minus mc square. So this indicates that we have to take the mass of electron equal to minus m. So after ejection of that electron from negative energy state or vacuum, the mass of the remaining vacuum will be what? That is m, and that m will be equal to initial mass, that is m naught minus m. So this will be m naught plus m, and so this is greater than m naught. Okay, greater than m naught. So you know the unperturbed charge and mass of the negative energy state, and you have calculated the charge and mass of the vacuum after creation of hole. So what are actually the values of change in charges, change in charge and mass of the vacuum? You can easily find. So I have mentioned it here. You can see the changes in the charge and mass of the vacuum are what? If change of charge is delta Q, then this will be Q minus Q naught. Q is the final value and Q naught is the initial value, and you can see from here that this is actually equal to minus E. But since minus electron's charge is minus E, negative electron's charge is negative, so this minus and minus E will be actually equal to plus E. So the hole created will have definitely a positive charge that will be equal in magnitude to the electronic charge, but in sign it is positive. Okay, electron's charge, you know, is actually negative, and the hole created will have a charge plus E, that is equal in magnitude to the charge of electron but opposite in sign. So I have written here that it is evident that relative to the vacuum, the hole has the same mass. Mass is in fact plus m, which is mass of electron, and as the positive energy electron, but has a charge that is equal in magnitude but opposite in sign to the charge of electron. Okay. So in other words, you can say that hole appears as a positively charged electron because mass is same as that of the electron in the positive energy state, and charge is actually equal in magnitude of the charge of electron, but in sign it is positive. So this hole is denoted by the symbol E plus. You know the electron is denoted by the symbol E minus. So on that basis, the hole will be denoted by the symbol E plus. Okay. Now let us see. In fact, in this whole process, you can see that this whole process consists of the disappearance of the quantum of electromagnetic radiation or photon. The photon gets absorbed by the electron in negative energy state, and at the place of an electron which gets transferred to the positive energy state, there will be a positron. That positive charge is, the hole is also called positron. Okay, and now there you can see in this phenomenon we have an electron in the positive energy state here, you can see, and a positively charged electron at the negative energy state, that is in vacuum. So this is just the phenomenon of pair production. This electron and this hole, which is also called positron, these are called pair. So this is just a phenomenon of pair production. Okay, and this hole is also called the positron, and positron is also called antiparticle of electron. So this was a great achievement of Dirac's theory, that it predicts that every elementary particle has an antiparticle. This was a very important consequence of the Dirac theory that it predicts the existence of antiparticle. Just like a particle exists, so if a particle will exist, definitely there will be an antiparticle which will also exist. Okay, so this Dirac theory actually predicts the phenomenon of pair production. Okay, and in pair, one is particle and another is antiparticle. Okay, now the hole which is created in the vacuum does not last long, as an electron from the positive energy state soon fall into it and giving up the excess energy which is greater or equal to 2 mc square in the form of quantum of electromagnetic radiation. And so in this process, both the electron and the hole disappear, and this phenomenon is thus the reverse of the pair production, and it is known as annihilation. You can see this phenomenon in this second figure. I have shown it here. In fact, in first figure you can see that an electron has been transferred due to the interaction with the gamma photon to the positive energy state, and a hole is created in the negative energy state. But as I have told you, that this hole does not last long. Its mean life is very short. Why? Why its mean life is very short? In fact, the electron which transfers from this negative energy state to this positive energy state, this electron actually now make a transition from this positive energy state to the negative energy state. And when this electron comes to the negative energy state, then this electron recombine with the positron or the hole in the negative energy state, and actually in this process the existence of this electron and positron are destroyed. And in fact, when you know that the energy of this electron in the positive energy state is equal to what? This is actually greater or equal to 2 mc square. Okay, so when this electron will make transition from this positive energy state to the negative energy state, as you can see, then a gamma photon will be emitted, and the energy of this gamma photon will be greater or equal to 2 mc square. So here you can see that the electron and its antiparticle positron gets combined and being annihilated, and in this process this much energy, that is greater or equal to 2 mc square, is emitted in the form of gamma radiation, or you can say electromagnetic radiation or gamma photon. So this phenomenon is called annihilation. So Dirac theory successfully explains two phenomena, the pair production, and so it predicts the concept of antiparticle, that every particle has definitely an antiparticle. Okay, and at the same time it also predicts the phenomenon of annihilation. Okay, now actually the problem predicted by Dirac theory has been experimentally observed. This was just a hypothesis of Dirac, and on the basis of two hypotheses Dirac explained the negative energy state of the electron. But after the advent of Dirac theory, so many people, so many scientists has verified it by experiment, and it was confirmed by experiment, and so now it is a valid theory. Okay, and as I have told you that this theory gives the existence of antiparticles as well as the particles. Okay, the particles are described by the positive energy solution for the Dirac equation, and the antiparticles are described by the negative energy solution. Okay, so in this way Dirac theory successfully explained the existence of the negative energy state. This is a very remarkable fact, that the solution of positive energy for Dirac equation is for the particles, and the solution of Dirac equation for negative energy state is the solution for the antiparticle of that very particle. Okay. So finally, we conclude that this whole theory results to a new fundamental symmetry in nature. And what is that new fundamental symmetry? You should remember it. To each particle, there is an antiparticle. To every particle, there corresponds an antiparticle. And in particular, the existence of electrons implies the existence of positrons. So if a particle exists, then there will be certainly an antiparticle. Okay. So this was actually a very important conclusion which we obtained from the Dirac theory. And so this is just a revolutionary theory, because after this theory, so many hidden facts of our nature was on the floor. In the floor or in the light, you can say. The facts which was actually hidden in darkness, now they were come into the light, and the people were acquainted of it. Okay. So in this way, you can explain how the negative energy state of electron or the Dirac particle can be explained on the basis of this Dirac theory. I hope you have understand. Actually, there were not so many mathematical calculations in this lecture, because this is just a logical fact, and you should note down these facts, because for your convenience, I have written each and every facts in language for your convenience, so that you can easily write the answer in your examination. Okay. So if you will note down these things in your notebook, that will be just a good notes for your examination. Okay. Thank you very much.